All right, assignment 5. And these are the solutions real quick. You should have checked these already. They're available online. But here they are real quick. You can pause it if you need to look at it. All right, so check all those. This is just the answers. This is what they should look like. I'd be checking them as I do them. And here are the answers on the back. So I'm going to go through and work these out. You can fast forward through ones that you got right or figured out what you did wrong on your own, which would be really beneficial if you can figure them out on your own. So these first ones, this is just, x equals plus or minus 2, right? So that's fine. I did write these in sort of like a set notation, which is kind of like interval notation. So if it's a list of separate numbers, you use these curly braces. So either way, this one right here, you could use that line. This is the middle. You can go 4 away on both sides. You're looking for things that are 4 away from 3. They're going to be solid dots because it's equals to. And so that'd be at 7 and 1. And then those are your answers. So x equals 1 and 7. Sorry, negative 1 and 7. Or you could write it like this set notation, which I don't really care that much about that. This one right here. Even the ruler postulate is kind of helpful on absolute value equations. You could do that here. Also, you could say, well, the middle is 0. Let's go 2 away on both sides. And then you're at negative 2 and positive 2. So I also like it because it's actually making you think of what the definition of absolute value is. It's distance on a number line. So this is going to be at negative 2, 5 away, both sides. So there's going to be open dots. That's going to be at 3, negative 7. It's going to be distances smaller than 5. So it's got to be between. So definitely want interval notation for these answers. Okay, same thing here. Middle's at 3, 1 away, open dots, 4 and 2. We want distances more than 1. So that's here and here. So negative infinity to 2, union 4 to positive infinity. This one has this 2 here, so you want the coefficient in front of the 1, in front of the x to be a 1, okay? But this guy gets divided by the 2 also. So the absolute values are still there, but now you do your number line 3, 6, 6, solid dot, 9, solid dot, negative 3. We want distances smaller than 3 away, so it's got to be in between. So negative 3 to 9. Brackets. So I think that's a pretty nice trick. Next one says represents all the points x such that the distance from negative 3 is at least 4, right? Just interpreting, right, what we've been drawing pictures of. Okay, number 7, we can do these on these more complicated ones. We can say, okay, well, the middle is at 4. We want to go 2 away. And then we want to go 5 away from the middle. So the 2 away, these are going to be solid dots at 2 and 6. And then 5 away, we're going to be solid dots at 9 and negative 1. And we want the distance, we want all the points that are more than 2 away, but less than 5 away. So that's these little chunks right here. So negative 1, 5, brackets, union, brackets, 6, 9. Middle's at negative 2, 1 away, 1 away, 3 away, 3 away, open dots at the 1 aways. So that's going to be at negative 1 and negative 3. And solid dots at the points 3 away. And so that's going to be positive 1 and negative 5. So -5 to -3, union -1 to 1. Okay, number 9, something a little tricky, but I give you a hint. I say, hey, you know what? Why don't, the point here is to kind of realize that this is sort of like a quadratic, even though it's kind of crazy. But this is something that we're going to actually kind of an idea we're going to use in a lot of different situations this year in calculus of making something complicated look simpler at first and solving the simpler problem and then getting back to what it originally was. So if we replace all the absolute value of x minus 3's with u, it'd be u squared minus 4u minus 12 if we move it over to this other side equals 0. And they're like, oh, this is a quadratic trinomial, so we could factor it, u and u, minus 6 plus 2 gives you -12, that's a -4, so u equals 6 and u equals -2. So then we'll go back and say, okay, well, the absolute value of x minus 3 equals 6, right? And then we'll solve it. So we'd say, okay, well, you could do the little number line thing here. Say, okay, well, here's 3. We're going to go 6 away. I mean, you could use strategies from Algebra 1 if you want. It's going to be 9, -3, no shading. This one, absolute value of x minus 3 equals -2, is not possible. Absolute values can't equal negative, so your answers are going to just be -3 and 9. Okay? So, got to get a little creative. Now, problem 10, these ones with double absolute values in them, I'm not going to use that rule of postulate. On this one, if it's just equals, I say, well, the inside of this equals the inside of that. And then the other situation is the inside of one equals the negative of the other. Now, technically, there's 4 scenarios, but it's redundant. If you do the negative equals the negative, it's the same as the positive equals positive. If you do the positive equals the negative, it's the same as the positive this equals the negative that. So we don't have to do it that many. So nothing too crazy here. Just going to solve each of these. X equals 12. Get all the x's on one side, get the other numbers on the other side. 3x equals -2. So x equals 12 and -2/3. And you could write that, if you write in set notation, it should be in order left to right. And a lot of times I write my answers in order left to right anyways, just out of niceness. Okay, same thing here. Inside of this equals the inside of that. And then also the inside of one of them, either one equals the negative of the other one. Now you got to distribute that negative to everything in there, okay? Minus x, plus 1, 2x equals -3, x equals -3 halves, plus x, plus 1, 4x equals 5, x equals 5/4. So that's the best strategy on those, when it's absolute value equal to an absolute value. Now, these ones, the less than greater than ones, it's going to be crazy if you kind of try and break it up in all the different scenarios. So we talked about this trick in the notes yesterday. What if we square both sides? The inequality should retain its true or falseness. And we can get rid of the absolute values because we're squaring it and forcing it to be positive no matter what. So this is going to be x squared plus 6x plus 9 less than x squared minus 4x plus 4. And now it's just a polynomial inequality like we've been doing in previous days. So you want to get everything on one side. Well, you might decide not to because the squareds drop out. I mean, you could keep going, but at this point it's a linear inequality. So you might just go with getting the x by itself. But this would be 10x plus 5 is less than 0. And you could do the whole line check thing. You could do, factor out the GCF, just make it a little easier. find the zeros, put on a line, so open dot, test one region. I like test far right, say 0. Everything is positive, which is false, true. There are your answers, negative infinity to negative 1/2. Okay. All right, same strategy on these ones. Square both sides. We're going to get 4x squared minus 4x plus 1 minus x squared plus 6x plus 9. Now this one is going to stay quadratic, so move everything to one side. Compare to 0, 3x squared minus 10x minus 8. And then try and factor it. I mean, that's going to be the quickest, even if you have to try a couple different things in your head. So it's definitely a 3x and x, and it's got to be a plus and a minus that multiply together to get 8. So it's either like 2 and 4 or 1 and 8. We want a negative 10 in the middle. So if we did like 4 here and 2 here, I think that would work. 4 here, that give you negative 12, plus 2 here gives you negative 10. So x equals negative 2/3, and 4, those are your zeros. So now we got to put in a number line. These are open dots. Left to right, smallest greatest, test a value, write down what you're going to test. I need to see this written down to give you credit on your test and stuff. So if you put 5 in, it's all positive, which is false, true, false, negative 2/3 to 4. So this is by far the fastest way to do these. Square both sides. 9x squared plus 12x plus 4 less than or equal to x squared minus 8x plus 16. Subtract x squared. Move everything on one side. So we get 8x squared plus 20x minus 12 less than or equal to 0. Keep that inequality symbol, write the 0. We could take a GCF out of 4, which is going to make any solving method easier. Makes the number smaller. We could try and factor it. Be a 2x and an x for sure. And then plus or minus 1, plus or minus 3. But we want positive 5 in the middle. So I think we want the plus 3 here to give us 6, and the minus 1 here to take away, leave you with 5. So x equals 1/2. X equals negative 3. Line check, solid dots. Don't lose points on your test next week because you didn't put, solid dots and mess up your final answer, parentheses, brackets. I'm going to test 0. It's going to be negative, which is true. Oh, I don't want to test 0. I want to test 1. Something to do about it. You can test 0 if you want. If you plug 1 in, it's all positive, which is false, true, false. There you go. All right. Now, I think that answer might have been wrong on the solution. So, do a couple more on the back here. This is just some problems that don't involve absolute values, but we've been doing. So, opportunity to get a little extra practice. I mean, we just got practice doing the top ones, though. So, move everything one side. Greater than 0. Factor it if possible. If not, we're going to do quadratic formula. I think we have the 4 here, positive 8 minus 1. Perfect. Find the roots, the zeros, put them on the number line, open dots, test a value. X equals 1, positive, 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 true, false, true. So the answer is negative infinity, negative 4. Union, 1/2 to positive infinity. All right, next one. Move everything on one side. Subtract 3x, subtract 18. We try grouping. Take x squared out, x plus 4. Take a minus 3 out, x plus 6. Nope, that's not going to work. So guess what? Get to do your favorite thing. P over Q. This is your P's. It's got to be on the version where it's all equals 0. This is your Q's. So that's your Q's, that's your P's. So Q's are just going to be plus or minus 1. So the nice thing about this is that the P over Q list is going to be the P list. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. I like to just put them in order. Think of all the different possible numbers that could be involved in multiplying with one other number to get 18. And I'm going to start at the beginning of the list, smallest numbers, positive ones first until I find one that works. So I got to plug these in here until one of them gives me a 0. If I plug 1 in, I get 5, minus 3 is 2, minus 18 is negative 16. Nope. How about negative 1? Negative 1 plus 4 is 3, plus 3 is 6, minus 18 is negative 12. Nope. How about positive 2? 8 plus 16 is 24. Minus 6 is 18. Minus 18 is 0. Positive 2 works. That's the root. So now we're going to use synthetic division. Put all the coefficients in order. If any are missing, put a 0. None are missing this time. Drop the first number down. Multiply by 2. Add these together. Repeat. And at the end, you better get 0. Otherwise, something's wrong. You picked the wrong root. Or you did your synthetic wrong, you missed a missing term or something like that. Don't fake it. If it's not 0, figure out where you went wrong. So now that we get x minus 2 from that 2, right? That doesn't disappear. And then we get x squared plus 6x plus 9. And we still have less than or equal 0. And then at this point, don't do rational theorem or synthetic anymore. And this is just quadratic. You should be able to factor it. If you can't, you got to use quadratic formula. Plus 3 plus 3. It might be worthwhile to go ahead and rewrite the common factors together with the power, because then you'll be like, oh yeah, x equals 2, x equals negative 3, but I got to make sure I don't change the sign on that one because it doesn't actually go through the axis. So then we're going to do a line check. These are solid dots. Test a value. Tell me what you're testing. Far right, it's my favorite. Everything's positive, which is false. True, true. Stays true on both sides there. So your answer is negative infinity to 2. Don't break it up at negative 3 because it's solid dot. It was open dot. You got to break it up. All right. A little rational inequality. So x equals 1, but it has a squared. X equals negative 2, which is okay. This is going to be x equals plus or minus 3. Those are vertical asymptotes. There's 2 of them. All right. 2 ways to make this equal to 0. So the line check is going to be solid dot at negative 2, open dot at negative 3. Anything from the bottom is going to be open because it's undefined. Solid dot at 1 and open dot at 3. And we got to make sure we keep track of that 1 right there. Test the value. X equals 4. Positive, positive, positive. False, true, stays true, false, true. So negative infinity, negative 3, union, bracket, negative 2 to 3. Don't break it up at 1. That one's a fast one. Next one, you're going to have to do a bit of work because we got to get everything on one side equals 0. Do not cross multiply. Do not cross multiply. Everything on one side equals 0. Give them these common denominators. Write them down if you need to. If you don't, that's fine. Do it in your head. Just be careful. Now, when I multiply this on top, I'm going to multiply the negative with it too. Just get that done. All right, so it's going to be x squared plus 6x minus 6x minus 10. Leave the bottom factored. So move everything on one side, give them least common denominators, combine them in single fraction. Simplify, combine like terms on the top, bottom leave factored. Now let's try and factor the top. Now top, I'm looking at that, I'm like, oh, that's a different squares, x plus square root of 10, x minus square root of 10. You know, so x equals negative 6, x equals negative 5/3. x equals plus or minus square root of 10. So now square root of 10 is about 3.1 or 3.2. It's between 9 and 16. It's between 3 and 4, right? Anything from top's going to be solid this time. Bottom's going to be open. We don't have anything to even power, so -6 is the furthest to the left. Negative root 10. I don't want that decimal in any answers. That's just for you to figure out where to put it on your number line. Next one's going to be -5/3. Next one's going to be positive square root of 10. Test the value. You can test far right if you want. 4. Plug it in here. 16 minus 10 is positive. Positive, positive, everything's positive. False, true, false, true, false. So final answer is -6 to negative root 10, parentheses, brackets, -5/3 to positive root 10. There you go. So I hope you guys feel like you're getting good at this stuff. Me too. Get really good at this. Algebra level work. We're not really doing any calculus here, but we're going to use this stuff a lot this year. So you want to be good and fast and accurate with this. So figure it out now. It'll pay off throughout the year.